This is Dinesh Kumar from Mechanical Department. I am going to present about the thermal power plant. The basic principles of steam power plant, which is also called as thermal power plant. The heat produced for burning of coal and with the help of the water steam is produced. This produced steam flow towards the turbine. Kinematic energy is converted into mechanical energy. The basic energy conversion is process of chemical energy, which is made up of fuel or coal, which is converted into heat energy in a boiler, and which is also converted into mechanical energy in turbine, and also converted into electrical energy by means of generator. This is the basic energy conversion process. And the input of steam drives mover to turbine, and simultaneously the generator also to rotate. At the time of mechanical energy is converted into electrical energy. In basics of steam turbine of thermal power plant, the steam is important medium for producing electrical energy. A grouping or a system of equipment which converts the available of heat energy of a steam into a mechanical energy and then into an electrical energy. It's also known as steam or thermal power plant. In order to the pressure range may vary from 1 bar to supercritical pressure at the temperature of range of to vary from 250 degrees Celsius to 650 degrees Celsius. And the development of thermal power plant becomes a necessary and advantageous one of about 60% of total power development in India is by thermal power plant only. And moreover, the thermal power plant can perform two purposes. Number one, generation of electrical power only, and number two, generation of electric power along with the production of steam, which could be used for other industrial purposes also. And now we are going to see about the working principle of steam power plant. And first, the steam is generated in the boiler by utilizing the chemical energy released due to the combustions of fuel. Next, the steam generated in the boiler is then expanded in the prime mover. It is also called as a turbine, where a part of heat energy of the steam is converted into a mechanical energy. And then the turbine is coupled to an electric alternator, or also called as a generator, which converts the mechanical energy into an electrical energy. This electrical power is produced in steam power plant. Since only the part of heat energy is expanded in turbine, the remaining part of the energy is condensed in the condenser, and resulting the condensate is then supplied back to the boiler with the help of a feed pump, and a cycle is repeated. These are the basic working principles of a steam power plant. Next, we are going to see about the selection of site for thermal power plant. In this, initially we want to consider the first main requirement is called as supply of fuel. Main supply of fuel is a raw material is called as a coal. The steam power station should be located near the coal mine, or so that transportation cost of fuel is minimum. If the land is not available near the coal mines, then we can provide adequate facilities for transportations of fuels, like near to the sea, or near to the railway station, or near to transportation facilities. Next, the availability of water. It is a major source for a thermal power plant. A huge amount of water is required in boiler and condenser, so that the plant should be located near the river or lake, which is very adequate. And then major issue is a transportation facility. For steam power station, provide better transportation facility for a transportation of man, machinery, and raw materials, etc. And then the cost and type of land. The steam power station should be located where the cost of land is cheap, and also the future extension is possible. It is low cost land is highly preferable for a steam power plant. Next, the near to a load center. In order to reduce transmissions and distribution losses, the plant should be located near to the load center. Next, distance from the populated area, as the thermal power plant produce flue gases, and these gases will affect to live human beings, so that the plant should be located away from thickly polluted area, mostly avoided from a livelihood. And then disposal facilities provided, as the thermal power plant produces ash will while burning of coal, so the disposal of ash facilities should be provided. It is very mandatory for a thermal power plant. And then earthquake, the area under the thermal power plant should be free from the earthquake to avoid the natural hazards. And the availability of labor, skilled and unskilled labor should be available nearly. To the extent possible, the thermal station should be far away from aerodrome. Next, it is a general layout of thermal power plant. In general layout, we have there are two sectors. Number one, cold storage and air-filled storage. In cold storage, coal is transported from the coal mine and stored in a cold storage device, and then it is handled by using coal handling, like it make a fine meshes, and then it is sent to the boiler to burn the coal. Now the coal is the raw material which is burned in a boiler, and which is used to heat the water, and then superheated steam is then sent to the steam turbine, and then steam turbine, when steam turbine superheated steam sends, and its steam turbine rotates, and then by means of steam turbine rotates, the generator also going to be rotated, and then electricity, alternate current should be produced. Three-phase power transmission is and transmitted, and then it is converted into by a transformer from AC to DC for a future usage. And then the superheated steam from the steam turbine, which is extract from the steam turbine, which is sent to the condenser, and the condenser is the main process of doing a process of converting by superheated saturated steam into a normal water. The condenser is a cooling purpose. In this cooling purpose, the hot water is ejected from the cooling tower, and then it is cooled by the cooling tower, and then sent to the cooling water pump, and then also sent to the condenser, which reduce the steam from the steam turbine. And then from the condenser, the steam condensated extracted from is used to pump from the condenser steam, and then sent to a low heater pressure heater, which is used for a steam turbine, and then it is sent to the feed pump and the high pressure heater, and then also which is sent to the feed pump, and there is an economizer used for a reheating purpose, which is used in a boiler, and then by means of economizer, then the sent to the air preheater. Exhaust steam is used for a air heater, and air preheater is used to reheat the steam, which is to the hot air is sent to the boiler for a heating purpose. And then by means of air filter is used for a air preheater, and flue gas from the boiler which is burned from the boiler, which is sent to the chimney for a exhaust gas to the environment. And then when boiler is used by the coal and flue gases, which is deposited, burnt fuels are in a boiler, which is used for ash handling and ash storage. Ash handling is the main impact, which is impact on a steam power plant, which is the main to eject from a ash handling storage. These are the general layout of a thermal power plant. Next, we are going to see about the layout of steam power plant has the following circuit. Mainly there are 4 circuits. Number 1, fuel and ash circuit. Number 2, air and flue gas circuit. Number 3, feed water and steam flow circuit. Number 4, cooling water flow circuit. Now we can detailedly see about the layout of circuit of a steam power plant. Number 1, coal and ash handling. Coal from mines is delivered by ship, rails or trucks to the power station, and then coal is received at a coal yard, which is available in a steam power plant. and coal is sized by crushers and breakers, which is by using coal handling purposes. Next, the sized coal is stored in a cold storage, and then from stockyard the coal is transferred to the boiler furnace by means of a conveyor and also the elevator. The coal is burnt in the boiler and ash is formed. Ash coming out of furnace will be too hot and dusty and accompanied by poisonous gas also. The ash is transferred to the ash storage. Generally, the ash will be quenched to reduce the temperature and the dust content, which is next sent to the outside of the power plant station. Next circuit is an air and flue gas circuit. Air is taken from atmosphere by the action of FD fan. It is passed through an air preheater. The air preheater by the flue gas is the preheater. This preheated air is supplied to the furnace to aid the combustion of the fuel. Due to the combustion of the fuel, the flue gas are formed by means of a chemical reaction, which is formed on a gas. Flue gas will be formed. These flue gases from the furnace pass over the boiler tubes and superheater tubes. Then the flue gases pass through the economizer to heat the feed water. After that, it passes through the dust collector. It is then exhausted to the atmosphere through the chimney to the atmosphere. Next, we are going to see about the water and steam circuit. The water is preheated by the flue gas in the economizer. This preheated water is then supplied to the boiler drum, and then heat is transferred to the water by the burning of the coal. Due to this, water is converted into the steam. The steam is raised in the boiler and then it is passed through the superheater. It is superheated by the flue gases, and then this turbine drives generator to produce the electricity power. The expanded steam is then passed through the condenser, and in the condenser the steam is condensed into water there to the circulator. Now we are going to see about the cooling water circuit. In cooling water circuit, the exhaust steam from the turbine is condensed in the condenser, and then the condenser, the cold water is circulated to the condense and the steam into the water. The steam is condensed by losing its latent heat to circulating the cold water. Hence the cold water is heated. This is hot water is then into a cooling tower. In cooling tower, the water is sprayed from droplets through the nozzles. By means the cooling tower used for cooling the condensed water. The atmospheric air enters into the cooling tower from the openings provided at the bottom of the tower. The cold water is again circulated to the pump, the condenser and the cooling. Some amount of water may be lost during the circulation. Hence, its makeup water is added to the pond by means of a pump. This is a schematic arrangement of a thermal power plant, and it is used for a boiler. Boiler is it records fuel and air from the atmosphere. In boiler, the steam is the water is heated into supersaturated steam, and then it is sent to the turbine. In turbine blades rotate by means of a superheated steam, and then turbine by means of rotating turbine, electricity generated also to be rotated by means of a mechanical energy. And when the turbine supersaturated steam power is ejected, then the normal saturated steam is out from the turbine, which is passed to the condenser to a condensate process. In condenser, by means of to condensate, the normal water, warm water is sent to the condenser, and then it is circulated by the cooling tower, and it is chilled by the cooling tower, and then also recirculated to the condenser. When the condenser stream water is condensated by means of feed water pump, and then it is recirculated to the combustion chamber or a boiler. and then the combust gas, it is stacked, it is sent to the stack, it is nothing but a chimney by to eject the unwanted gases from the turbine and the boiler. Next, this is the arrangement of a schematic arrangement of a thermal power plant. It is the above figure shows the schematic arrangement of thermal power plant, which is handling the ash storage and cold storage. Cold storage is the main raw material which is sent to the cold storage. And next, the coal is handling by coal handling plant, which is finely sized and handled by means of a coal handling plant. And then it is sent to the mill, and mill by means of it is sent to the boiler to burn the water. In the boiler, there is a drum. The drum which is contains of a water which is heated by the gases which is from the coal. In this, there is a superheater and economizer and preheater in a boiler, which is used to reheat purpose of a steam. When the water is superheated, and then it is sent to the through means of valve, and that valve is used to operate the turbine. If we want to close the valve, there is no supply to the turbine. If you open the valve, the superheated steam is passed through the turbine, and which rotates the turbine blades, and by means of coupling the generator also to be rotated, and the electricity, which is AC power supply, is to be produced, and then AC is transferred by means of transformer, and power should be stored. The gas from the turbine, which is ejected from the turbine, which is sent to the condenser. By means of condenser, that is the condensate water purposes to be handled by means of cooling water pump and the cooling towers. The sea water is taken from, and it is cooling condensate process is carried out, and then it is ejected to the water treatment plant, and then it is sent to the feed water pump. By means of feed water pump, which is also sent to the economizer, and again it is returned to the drum, and it is a repeated cycle to be followed. And then from means of air preheater, it is sent to the turbine. There is an FD fan and FA fan, which is used for eject the heat from the chimney, from the boiler, which is sent to the chimney to the atmosphere. And there is an ash handling, which is below the boiler, which is used for a ash handling plant, and it is stored in a ash storage. Next, we are going to see about the major components of a thermal power plant. Number 1, ash and coal handling and arrangement. Number 2, steam generating plant. Number 3, steam turbine. Number 4, alternator. Number 5, feed water. Number 6, cooling arrangement. The function of each part used in a thermal power plant station are: number 1, coal storage and coal handling plant, which is diagram shows that the IP coal from coal mines by means of a road or railways, and it is sent to the coal storage sector, and then sent to the coal handling plant, which is used for a fine mist coal has been crushed, and then it is sent to the boiler to burning purpose. The coal is transported to the power station by means of road and rail, and it is stored to the coal storage plant. And storage of a coal is a primary matter, and which is used to a matter of protection against coal strikes. The failure of transportation systems in the coal storage, and the main purpose of the coal handling system is the large quantity of coal is required as a fuel in a furnace of a boiler for combustion to produce heat energy for production of steam. For this purpose, coal handling unit is mainly used. Next, purpose of coal handling. Number 1, coal delivery. Number 2, coal delivery from the coal minings. Number 2, coal unloading from transportive vehicles. Number 3, cold storage. Either it may be in outdoor storage, it is also called as dead storage, or indoor storage, which is also called as a live storage, which is available in a plant. In the plant, the coal is crushed into small pieces with the help of crusher and breaker. The coal is crushed to 2.5 centimeter or then less. Then it is cleaned by passing the force air to remove the dust content available on a coal. Then it is dewatered to remove of moisture with help of a dryer. Mostly the moisture content must be less than 2% after the drying operation, which is very mandatory for a coal handling process. Then it is passed through the magnetic separator to separate the iron particles mixed in it. Then the coal is passed through the pulverizing mill. Pulverizing mill is used to pulverize the coal into fine particles. The pulverized coal is used to weighing process to study about the coal weight process. Then the pulverized coal is then transferred into the boiler furnace. Next, number 2, ash handling and ash storage. The removal of ash from the boiler furnace is necessary for proper burning of coal. It is worthwhile to give the passing reference to the amount of coal burnt and ash produced in a modern power station. A 100 megawatt station operating at 50% load factor may burn about 20,000 tons of coal per month and produced may be to tune 10% to 15% of coal fired. For example, 2000 to 3000 tons. In fact, the thermal power station above 50 to 60% of total operating cost consists of fuel purchasing and it is handling. In coal, the large quantity of ash, about 10% produced in a furnace. The removal of ash from a boiler furnace is necessary for efficient combustion. For this purpose, ash handling is used. The diagram shows the ash from the boiler is ejected from the boiler and then sent to the ash handling plant and then also stored in a ash storage. Next steps for ash handling. Before handling the ash, it is desirable to quench the ash. The handling of ash includes number 1, removal of ash from furnace. Number 2, loading of ash on conveyor belt. Number 3, air delivered to the space where it can be disposed of. The various methods for disposal of ash are follows. Number 1, hydraulic system. Number 2, water jetting. Number 3, pneumatic systems. And number 4, mechanical ash handling system. And then now we are going to see about the boiler, steam generating plant. The steam is generated and the power is created on a boiler. A boiler is a cold closed vessel in which water is converted into steam by utilizing the heat of coal combustion. The heat of combustion of a coal in the boiler is utilized to convert water into steam at high temperature and pressure. The flue gas from the boiler make their journey through the superheater economizer and air preheater and finally exhaust to the atmosphere through the chimney. The major types of the boilers are number 1, fire tube boiler and number 2, water tube boiler. Now we are going to see about the fire tube boiler. The boiler is named so because of protection of combustion passed through the tubes which are surrounded by the water. Depending on whether the tube is vertical or horizontal, the fire tube boiler is divided into 2 types. Number 1, vertical tube boiler. Number 2, horizontal tube boiler. A fire tube boiler is a simple, compact and rugged in construction. Its initial cost is very low. Now we are seeing the diagram of a fire tube boiler. In this, the hot gas steam is from boiler. There is water surrounded by the furnace is used to burn the coal, and the heat is ejected from the furnace and passed through the boilers. By means of tubes, the fire and smoke has been passed through the hot gases through the fine tubes, and which is surrounded by water. The water to be heated and the steam is out from the boiler. This is the basic diagram of a fire tube boiler. Next we are going to see about the water tube boilers. In this boiler, the water flows inside the tubes and hot gases flow from the outside the tube. The circulation of water in the boiler is may be natural or be forced. Water tube boilers are classified into three types. Number 1, vertical tube boilers. Number 2, horizontal tube boiler. And number 3, inclined tube boilers. The diagram shows the inclined tube boilers, which is in this the combustion chamber used to combust the coal, and then burned air and fuel mixture sent to the burned air gases flow through the chamber, and the chamber there is an inclined tubes which is passed by the water. The water inlet from a feed water pump, and then it is sent to the inclined tubes, and inclined tubes the heat is transferred to the tubes and the water to be burned, and water tubes are used to burn the water, and water is heated and then it is sent to the steam outlet for a heat purpose, and the burnt gases is sent out through the flue gas chamber from a combustion chamber. Next we are going to see about the comparison between the fire tube boilers and water tube boilers. In fire tube boilers, the hot gases are inside the tube and the water is outside. In water tube boilers, water is inside the tube and hot gases is outside. In fire tube boiler, the operating pressure limit is limited to 25 bar, and water tube boiler can work under a high pressure as more than 25 bar. In fire tube boiler, the rate of steam generation is very low, and then in water tube boiler, the rate of steam generation is very higher compared to the fire tube boiler. And in fire tube boiler, not suitable for a large power plant, and it is very suitable for a large power plant which is used for a fire tube boiler, water tube boiler, and chance of explosion is less due to low pressure in a fire tube boiler. In water tube boiler, chance of explosion is higher due to the high pressure. In fire tube boiler, the flow space requirement is more. In water tube boiler, flow space requirement is very less, and cost is very less in a fire tube boiler and cost is more in a water tube boiler. And in fire tube boiler, required less skill for efficient and economic working, and in water tube boilers required more skill and careful attention for efficient and economic working. And number 9, for producing process steam, which is used to fire tube boiler. In water tube boilers, for producing steam for power generation as well as the process heating. In fire tube boiler, there is no problem of scale deposition and less problem of overheating and bursting. In water tube boiler, small deposition of scale will cause overheating and bursting of the tubes. Now we are going to see about the superheater which is used in a thermal power plant. The steam is produced in boiler is wet and it is passed through the superheater where it is dried and superheated. For example, the steam temperature increased above the boiling point of the water, then by the flue gas on the air to the chimney. A superheater consists of group of tubes made of special alloy steel such as chromium molybdenum. These tubes are heated by the heat of flue gases during their journey from the boiler furnace to the chimney. The steam produced in the boiler is led through the superheater where it is superheated by the heat of flue gas from the boiler. Next, the superheating provides two principal benefits. First, overall efficiency is increased, and then secondly, too much consideration in the last stage of the turbine. which would cause the blade corrosion, which is to be avoided. Then the superheated stream is from superheated and then is fed to the steam turbine through the main boiler. We are seeing the superheater layout. In this superheater is surrounded by from the burned gases from the furnace, which is sent to the superheater. Initially there is a superheated steam to the turbine. The feed was, now we are going to see about the water feed water tank. Feed water tank, the water is pumped from the feed water pump and sent to the feed water heater, and then it is sent to the economizer. Economizer is nothing but which is available in a superheater, which is used for initial heating of a steam, water into a steam, and then it is superheated by the superheated chamber, and then it is sent to the superheated steam to the turbine. And the burned fuel gases, initial air is sent to the air from the atmosphere, and burned gases is sent to the from means of flue gas chamber. The superheater mainly classified into two types. Number one, radiant superheater. The radiant superheater is placed in the boiler furnace between the water valves, which receives heat from the fuel burning through the radiation process. Next, number two, convection heater superheater. The convection superheater is placed in the boiler tube bank and receives heat from flue gas entirely through the convection process only. Now we are going to see about the economizer. Economizer is essentially a feed water heater and drives heat from the flue gas for this purpose. The feed water is fed to the economizer before supplying the boiler. The economizer extracts a part of heat and flue gas to increase the feed water temperature. This result is increase in the boiler efficiency, saving fuels, and economizer is alone gives only the 8% of increase. The feed water from a high temperature heater and enters the economizer, which picks up the heat from the flue gas after the low temperature superheater. Now we can see the diagram of an economizer. In economizer, the water is pumped from the river, and the water treatment plant is used to filter the water from a river, and then pumped by feed water pump, and the feed water heater is used to heat the water, and then it is sent to the economizer. Economizer, which is the economizer, the boiler fuel gas is used to heat the economizer. Now we are going to see about the reheater in a thermal power plant. In addition to superheater, modern boiler has a reheater also. The function of the reheater is to superheat the partially expanded steam from the turbine. This ensures that the steam remains dry through the last stage of the turbine. A reheater may be convection type or radiant type, or combination of both convection and radiation type. Now we are seeing the feed water reheater. The condensate from the condenser is used for feed water to the boiler. Some water may be lost in the cycle, which is suitably made up of external source. The feed water on this way to the boiler is heated by the water heaters and the economizer. This is raising the overall efficiency of the plant. The water stream flow diagram is shown in it, and in this the makeup water tank is used to the heat purpose of a feed water pump, and the cooling tower used to the condenser and condensate the process. The condensate pump and the low pressure heater is used to the deactivator, and the feed water pump is pumped, and high pressure heater is used, and then it is sent to the economizer, and economizer the boiler superheater, and then steam to the turbine, and turbine from a generator. This is the flow diagram of a steam. Next we are going to see about a air preheater. Air preheater increases the temperature of air supplied to coal burning by deriving from the flue gases. The air is drawn from the atmosphere by a forced draft fan. Forced draft fan is nothing but a draft fan is used to be force by means of external force, and it is passed through air preheater and before the supplying to the boiler furnace. The air preheater extracts the heat from flue gas and increase the temperature of air used for coal combustion. The principal benefits of preheater is generally shown in diagram. In this, the boiler from burned gas is passed from the flue gas which is used to air preheater, and hot air is recirculated, and forced draft fan is used for a preheating purpose. And preheating is an increase of thermal efficiency and increase the steam capacity per square meter of the boiler surface. Depending upon the method of heat transfer from the flue gas in the boiler to the air preheater can be divided into mainly two types: recuperative types and regenerative type. In the recuperative type, air preheater consists of a group of steel tubes. The flue gases are passed through the tubes while the air flows externally to the tubes. Thus, the heat of flue gas is transferred to the air. Next, the regenerative type. The regenerative type, air preheater consists of slowly moving drum made up of corrugated metal plates. The flue gases flow continuously on the side of the drum and the air on the other side. This action permits the transference heat of flue gas to the air being supplied to the boiler furnace for coal combustion. And then we are going to see about the condenser. Condenser is a device which condenses the steam at the exhaust of the turbine. It serves two important functions. First, it creates very low pressure at the exhaust to the steam turbine, thus permit the expansion of the steam in the prime mover to a very low pressure. And then it helps to the converting heat energy of steam into mechanical energy in a prime mover. This is also called as a turbine. And secondly, the condensed steam can be used as a feed water to the boiler. In condenser classified into two types. Number one, jet condenser. In a jet condenser, cooling water and exhaust streams are mixed together. Therefore, the temperature of the cooling water and the condensate in the same when leaving the condenser. Initially, the water-cooled surface type condenser are used to wet steam is sent to by means of from the condenser, and it is passed out the condensate out. The water is inlet from the one side and it is out from the cold water is inside and the hot water should be outside, which eject the heat from the steam. Next, the surface condenser. In surface condenser, there is no direct contact between cooling water and the exhaust steam. It consists of bank of horizontal tubes. The cooling water flows from through the tubes and the exhaust steam over the surface of the tube. The steam gives up its heat to water and condenses itself. The diagram shows that the surface condenser. The surface condenser, the steam is inlet through the steam inlet and it is exhaust from the air outlet by passing through the tubes. In cooling water, the inlet is sent from one side and the other side cooling water outlet is to be passed through the fine tubes. Now we are going to compare about the jet condenser, contact type, and surface condenser, non-contact type condenser. In that, number one, the exhaust steam mixes with cooling water. In surface condenser, steam and water do not mix. In jet condenser, the temperature of condensate and cooling water is same while leaving the condenser. In surface condenser, the condensate temperature higher than the cooling water temperature and outlet. And in jet condenser, the condensate cannot be recovered. But in surface condenser, the condensate recovered is feedback to the boiler. In jet condenser, the heat exchanged by direct conduction, but in surface condenser, heat transferred through the convection. And initial cost is very low in jet condenser and initial cost is high in the surface condenser. In jet condenser, the high power required for pumping water. In surface condenser, the condensate is not wasted to pumping power, it's less. Next, we are going to see about the deactors. Deactor is a device that is widely used for removal of oxygen and other dissolved gas from the feed water to steam generation boilers. In particular, the dissolved oxygen in boiler feed waters will cause a serious corrosion damage in the steam systems by attaching the wall of metal piping and other metallic equipment and forming oxide. For example, rust. In cooling tower, the cooling tower is used to reduce the temperature of water coming from the condenser and reused the same. And it is used in the case of thermal nuclear power station and for similar application. Next, we are going to see about the working of a cooling tower. The water coming from the condenser is dropped in the cooling tower from height of about 8 to 10 meter. The cooling tower reduces the temperature of the hot water by about 7 degrees Celsius to 10 degrees Celsius. This water at the reduced temperature is recirculated to the condenser and the cycle is repeated. The cooling tower temperature of water is reduced either by natural or forced by induced draft method or by combined method. The function of cooling tower is to reduce the temperature of water coming from the condenser. Now we are going to see about the diagram. In this diagram, the cooling tower, the large cooling tower fan is mounted on a top side, and which is water columns are formed in a cooling tower. And water is sprinkled by the hot water inlet and sprinkled from by means of sprinkler, and then it is formed by the cold water is drained by the cold water outlet. A cooling tower. Now we are going to detailedly see about the cooling tower. A cooling tower is a steel or concrete hyperbolic structure. There is a reservoir at the bottom of a storing of cold water. Water is circulated from the basin of the cooling tower to the condenser. It absorbs the latent heat from the steam and get warm. This warm water is returned to the cooling tower to reduce the temperature. The hot water from the condenser outlet is dropped from the height of about 8 to 10 meter. In cooling tower, temperature is reduced by natural or forced or induced through draft method or combined. Next, we are going to see about the prime mover, which is also called as a steam turbine. A dry and supersaturated steam from the superheater is fed to a steam turbine through the main valve. The heat energy of a steam valve, when passing over the blades of turbine, which is converted into mechanical energy. After giving a heat energy up to the turbine, the steam is exhausted to the condenser, which condenses the exhaust steam by means of cold water circulation. The steam turbine is generally classified into two types according to the action of steam on moving blades. Number one, impulse turbine, and number two, reaction turbine. Next, we are going to see about the water treatment in thermal power plant. The boiler of the thermal power plant requires clean and soft water for longer life and better efficiency. However, the source of the boiler feed water is generally a river or lake, which may contain suspended and dissolved impurities, gases, etc. Therefore, it is very important that the water is purified and softened by chemical treatment and then delivered into boiler. Next, we are going to see about the draft system. In this draft system, the combustion of boiler is separate sufficient quality of water and quality of air and removal of excess gas. The circulation of air is caused by difference of pressure is known as draft. This draft is the differential pressure between 2 points. Draft tube may be a natural draft or mechanical draft. A natural draft is provided by a chimney or stack. A natural draft has a limitation. Modern plants has high rates of heat transfer and draft losses very high. In view of natural draft, it is used only for the small boilers. And now we are going to see about the mechanical draft. A modern large size plant used in very large size boilers of a capacity about 10 lakh kg per hour. Such boilers needs a terminus volume of around 2 lakh meter cube per minute. A chimney provides this, therefore a mechanical draft is used. In mechanical draft, the system's moved air is due to the action of fan. The mechanical draft consists of a forced draft. A mechanical drafts need additional capital investment and maintenance, but it is required proper operation of modern power plant. In super thermal power plant, each boiler may use two forces fans and two induced fan. Next, we are going to see about the function of a chimney. The flue gas like smoke are produced during the combustion process. These flue gas produce air pollution, so reduced air pollution should be passed in the air by high as possible with the help of a chimney. The list of major electrical equipment used in a thermal power plant. Number 1, alternator. Alternator is the steam turbine is coupled to alternator. Turbine is coupled to alternator. The alternator converts the mechanical energy of turbine into electrical energy. The electrical output from the alternator is delivered to the bus bars through the transformer and then circuit breakers and isolator. Number 2, exciter. Number 3, transformer. Transformer is a generating of different two types of transformer. Main setup transformer which set up the generation of voltage from a transmission of power. Station transformer which is used to general service. Example, lighting in the power station. And auxiliary transformer which is supplying individual unit auxiliaries. And number 4, switch gear. It is used in a locate fault and isolate faulty part from healthy section. It contains circuit breakers, relay switch and other control devices. And finally, we are going to see about the merits and demerits of a thermal power plant. The main advantages of thermal power plant is cost of fuel. The fuel used in thermal power station is cheaper than cost of fuel used in the diesel or nuclear power station. And capital cost is less than hydro and nuclear power station. And near load center. Thermal power station can be located near load center and the coal can be transported from a coal mines and the power. Next, the space required is very less and generating capacity is very low. Then the time required for a completion of thermal project is very less as compared to hydroelectric power station. And the merits of a thermal power plant is the life of power plant is 25 to 30 years compared to a diesel power plant which is about 2 to 5 years. Repair and maintenance cost is low when compared to diesel power plant. Initial cost is less compared to a nuclear power plant. It is suitable for varying load conditions. No radioactive harm waste from are produced compared to nuclear power plant. Unskilled operators can operate the power plant. The power generation does not depend on the water storage. There are no transmission loss as they are located near to the load center. Now we are going to see about the disadvantages in a thermal power plant. Air pollution. It produces the air pollution due to smoke ash produced during the combustion of a fuel. Next one, starting time. In thermal power plant cannot be put into service immediately like hydroelectric power plant as thermal power plant requires few hours, 6 to 7 hours to generate steam, high pressure and high temperature. Handling of fuel. Handling of fuel like coal and disposal of ash is quite difficult. And fuel transportation cost. When power plant are located away from coal mines, near load center and at that time fuel transportation cost is more. Preparation of fuel. There is more expenditure for preparation of coal, like raw material of coal to pulverize the coal. Next, space required. The large amount of space is required for the storage of fuel and ash as compared to the nuclear power plant. Next, the efficiency. It is less efficiency power plant. Overall efficiency is maximum 30%. And the disadvantage of thermal power plant are standby losses, standby losses more as furnace is required to keep in operation even when there is no load. And the maintenance cost, high maintenance and operating cost because number of auxiliary parts in the plant are required such as coal, ash handling plant, pulverizing plant, condensing plant and water purification plant. And the availability of fluid, less availability of high grade coal, simplicity and cleanliness. The layout of thermal power plant is complicated than hydro power plant due to the coal and ash. The life of thermal power plant is less than compared to the hydro power plant. And then the cost per unit, cost of generation is high. And the disadvantage of thermal power plants are less efficient than the diesel power plant. Starting up and bringing into the service takes more time, and the cooling water record is more, and the space record is also more compared to the other power plant, and the storage record for the fuel is more compared to the other power plants. And ash handling is a major problem in a steam power plant and not economical in areas which are remote for low coal fields, and manpower is required more compared to the other power plant. For large unit the capital cost is more. And thank you.